Welcome to this tutorial on Kubernetes event logs and cluster event monitoring. In this video, we'll explore how to understand and use Kubernetes events for effective troubleshooting. Events are one of the most powerful diagnostic tools available in Kubernetes, providing real-time insights into what's happening inside your cluster. Whether you're dealing with pod failures, scheduling issues, or resource problems, events will help you identify the root cause quickly. Let's dive in and learn how to leverage events to become more effective at troubleshooting Kubernetes applications. Kubernetes events are cluster-level objects that provide visibility into what's happening inside your cluster. They document resource changes, state transitions, and operations performed by various Kubernetes components and controllers. Events are automatically generated by the system whenever something significant happens, such as a pod being created, a container crashing, or a volume failing to mount. One critical thing to understand is that events are time-limited. By default, they are retained for only 1 hour, so if you don't check them quickly, you might miss important diagnostic information. Events serve as an essential diagnostic tool, capturing what happened moments before a problem occurred, making them invaluable for understanding pod failures, scheduling issues, and other cluster problems. They provide real-time insight that helps you react quickly to issues as they arise. Every Kubernetes event is an object with several key fields that provide detailed information. Let's understand the most important ones. The type field indicates the event severity, which can be either normal or warning. The reason field provides a short, machine-readable cause for the event, such as failed scheduling or pulled. The message field contains human-readable details about what actually happened, giving you context and explanation. The involved object field identifies the specific resource this event is about, whether it's a pod, node, deployment, or another Kubernetes object. Finally, we have timestamp fields. First timestamp tells you when the event first occurred, and last timestamp shows the most recent occurrence if the event happened multiple times. Understanding these fields is crucial because they form the foundation of how you'll interpret and troubleshoot issues using events. Kubernetes events are categorized into 2 main types. First, we have normal events. These are informational events that indicate successful operations and standard activities within your cluster. Examples include pulled, which means an image was successfully pulled, created, indicating a container was created, started, showing a container started successfully, and scheduled, meaning a pod was successfully scheduled to a node. On the other hand, we have warning events. These are problem indicators that require your attention. They signal failures, errors, or abnormal conditions that need to be addressed. Common warning events include failed scheduling, which means a pod couldn't be scheduled due to resource constraints, backoff, indicating a container crashed and Kubernetes is waiting before restarting, unhealthy, showing that a probe failed, and failed mount, meaning a volume couldn't be mounted. When troubleshooting, you'll primarily focus on warning events since they directly point to problems in your cluster. Now let's look at how to actually view events in your Kubernetes cluster using the kubectl getEvents command. The most basic form is simply kubectl getEvents, which lists all events in your current namespace. If you want to see events across all namespaces in your cluster, you can use kubectl getEvents with the all namespaces flag. One particularly useful variation is sorting events by timestamp to see the most recent events first. You can do this with kubectl getEvents sort by =last timestamp. This command is extremely helpful when you're troubleshooting active issues because it immediately shows you the latest events, helping you understand what just happened in your cluster. These commands form the foundation of event-based troubleshooting in Kubernetes. Another powerful way to view events is through the kubectl describe command. This command shows detailed information about a specific resource, and importantly, it includes related events at the bottom of the output. To view events for a specific pod, use kubectl describe pod followed by the pod name. For node-related issues, use kubectl describe node followed by the node name. And for deployment problems, use kubectl describe deployment followed by the deployment name. The describe command is particularly useful because it shows you both the current state of the resource and the recent events related to it, all in one place. This gives you a complete picture of what's happening with that specific resource. When you're troubleshooting a particular pod or deployment, Describe is often your first stop because it combines configuration details with event history. As your cluster grows, you'll have many events, and filtering becomes essential to find what you need. Kubernetes provides powerful filtering options through field selectors. To filter events for a specific pod, use kubectl get events with the -- field -selector flag, setting involvedObject.name equal to your pod name. To see only warning events, which are the ones indicating problems, use -- field -selector type equals warning. You can also filter by the reason field, for example, to find all failed scheduling events. Additionally, the -- watch flag lets you monitor events in real time, continuously streaming new events as they occur. This is incredibly useful when you're actively working on an issue and want to see events as they happen. Mastering these filtering techniques will make your troubleshooting sessions much more efficient. Let's explore some common event reasons you'll encounter related to scheduling and resources. Failed scheduling is one of the most common issues. It occurs when a pod cannot be scheduled because there aren't enough CPU, memory, or the node constraints prevent scheduling. Node not ready means the target node is not in a ready state to accept pods, possibly due to network issues or the kubelet not running properly. Insufficient memory indicates that no node in the cluster has enough available memory to schedule your pod. Similarly, insufficient CPU means no node has enough CPU resources available. These events are critical because they directly tell you why your pods aren't running. When you see these events, you know you need to either add more nodes to your cluster, adjust resource requests in your pod specifications, or investigate why existing nodes aren't ready. Now let's discuss common event reasons related to container issues. Backoff, often seen as crash loop backoff, means your container crashed and Kubernetes is backing off before attempting another restart. This usually indicates a problem with your application code or configuration. Image pull backoff occurs when Kubernetes fails to pull the container image, typically due to authentication problems, the image not existing, or network connectivity issues. Failed mount indicates that a volume couldn't be mounted. This could be because a config map, secret, or persistent volume is not available or doesn't exist. Finally, unhealthy events appear when liveness or readiness probes fail, meaning your container isn't responding correctly to health checks. These container-related events are crucial for diagnosing application-level problems. When you see these, you'll need to check your container logs, verify image availability, ensure secrets and config maps exist, and validate your probe configurations. Understanding event retention and following best practices is essential for effective cluster management. The most critical thing to remember is that events have a default retention period of only 1 hour. If you don't check events quickly after a problem occurs, they'll be gone, and you'll lose valuable diagnostic information. To address this limitation, you should export events for long-term storage using monitoring tools or log aggregators. This ensures you have a historical record for analysis and compliance. It's also highly recommended to set up alerts specifically for warning events. This allows you to catch issues before they escalate into major problems. Finally, when troubleshooting any issue in Kubernetes, always check events first. They often reveal the root cause immediately, saving you significant time. By following these best practices, you'll build a more reliable and observable Kubernetes environment. Let's put everything together into a practical troubleshooting workflow. Step 1, identify the problem. This could be a pod not running, a deployment that failed, or a service that's unavailable. Step 2, check events immediately using either kubectl get events or kubectl describe on the affected resource. Time is critical since events are only retained for 1 hour. Step 3, look specifically for warning events. Focus on events with type equals warning and examine their timestamps to find recent issues. Step 4, analyze the reason and message fields carefully. These provide the root cause and detailed context about what went wrong. Based on this information, take corrective action, whether that's adjusting resource requests, fixing image names, creating missing config maps, or scaling your cluster. This systematic workflow centered around events, will make you a more effective Kubernetes operator. Events are your first and best tool for diagnosing problems in Kubernetes. Master them, and you'll resolve issues faster and with greater confidence.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.